channel so that you don't miss out. So open an existing project, or from here we can also say file, recent projects, points. Okay, so let's build around this. So once it's run, we know that this okay. So this one is working fine. So we are going to want to declare our variables first. So the first thing we're going to do is to declare our variables. So say double want to double A, comma B, comma C, comma X1. So when you understand it properly, you understand what I'm using all these variables, right? X1, then we have X2, then X2 power, also have X3 power, X3, comma X3 power. We have our X1, X2, we have our discriminant, right? We have our root 1, we have our root 2, we have our root 1, also have our root 2, right? So we can terminate this now. So from here, you can, let's create a comment so that you can see what you want to do. So in this point, we will take the coefficient of x from the user and the power. Now we can see, let's make this a straight language. Okay, the next thing we can do right here is want to see out. So we say what? Enter coefficient of x. Let me use x1. Okay, and then can see in. You can see C in. So C in, what do you want to store in that? I want to store x1. And we terminate that. So what we're going to do now is we are going to copy. I'm going to copy this, and we are going to use it instead of rewriting it multiple times. So this one will say x1 power. Okay, okay, we say enter the power. Instead of coefficient this time it says what? Power of x1. So this one will not store this in x1 power, right? So we can paste this coefficient of x2 in this case. We'll call this also 2, right? So let's copy for power now. So x2 power. So we'll call this 2, right? x2 power, yes. Let's be x1 power, x2 power. Okay, so we need the coefficient for x3. So we need the coefficient for x3. So paste that coefficient for x3. Slash arrow s3. So store this for coefficient of s3. Yes. So we need the power for s3 also. So they can enter it and the calculator will do the rest. So you can say this is for what? x3 power. So we want to store this also in the s3 container. So I guess this is for x1, x1 power, s2, s2 power, s3, s3 power, s3 power. Okay, coefficient power, coefficient power, coefficient power. Okay, since we've done that, the next thing we are going to do now is we are going to calculate our differential calculation. You know, we then differentiated, right? We differentiated. Let me show you. At this point, we differentiated. Once we enter the coefficient, let me cycling it. When we enter the coefficient, then we enter the power. We enter the coefficient, we enter the power. We enter the coefficient, we enter the power. Then the coefficient and power multiply themselves. Coefficient and power multiply themselves, right? Coefficient and power also multiply themselves. So we got the coefficient and powers, right? So since we got that, for us to get this now, we need to multiply the coefficient and the power. So we're going to do that right away. So we're going to say we want to multiply the coefficient power. So we want to store the answers of the multiple. Let's say we want to store it in ABC because we're going to use the ABC for the quadratic equation, right? We're going to use it for the quadratic. So we can say we want to store this in A, and A should be equal to what? X1 times x1 power. So we can say x1 times x1 power. I just want to be very sure of something. X1, I want to double. So we're going to terminate this, okay? So next we're going to do is what? B is equal to what? X2 double times x2 power double. For the C in, they said the C in, so let's store it. Sorry, let's take the ones for the C in because it's what the enter we want to multiply. So let's take the ones for the C in. If it actually means anything, but if it doesn't, all good because it's still the same thing. X1 power C in. I want the C in variable. I want the C in. I want the C in. So I'm going to do the same thing also for the C. So for C equals to what? X3 C in times x3 c in power. Okay, so I'll terminate this also. So once I've done that, the next thing I want to do is what I want to calculate my discriminant. So because once the coefficient and the power have multiplied themselves, they are going to become my quadratic factorization. That is ABC. You know, when you want to use almighty formula or quadratic equation, you need to get your A, B, and C right. So let me state my discriminant. So I'm going to say in quotes, I will say in comments. So here I'm calculating my then discriminant, right? So this is how I want to calculate my discriminant. So I'm going to say discriminant double, where discriminant is equal to what? My discriminant is equal to what? B times B, because we have this B square, right? So B, so those that know what mathematics is, they know this point for discriminant B times B minus 4AC minus 4 times A times C. So this is my discriminant. So once I've got my discriminant, the next thing I want to do is what? I want to calculate the root. So this is my discriminant. I want to calculate my root in this case right now. So I will not say making a quote at this point. I want to what? Calculate my root. So since I want to calculate my root, I will say if in brackets discriminant, right? If discriminant is greater than 0, right? I want to open a function. So open and close curly bracket. So in this function, I want to say what? Root 1, that is root 1 double, should be equal to what? Root 1 should be equal to, in bracket minus b plus the square root okay, we did not declare. Let's be very careful. Let's declare the math function. I use string math. Include as I use string math.fish. Yes, include math.fish. So we declare it for mathematics. So it's going to recognize our square root. Okay. The square root of, in bracket, the discriminant, right? Then we have to close this bracket. Then all should not be what? Divided. All should be divided by that one 2a, right? Open bracket 2 times a. Okay, so from here we terminate this. So that is for root 1. Then for root 2 we just do the same. All of this when it is now what? Minus Ctrl C. So when it is now what? Minus. Okay, now we have minus plus minus b minus plus, right? So the next one we do is what? We want to now calculate. So since we've gotten our root, okay, we want to calculate x1. So we can say x1. Which one is x1? X1 is the second point. That is the second point. When we say x1, when we substitute the root for x in the y equation, okay? When we substitute the root for x in the y equation, let me show you what I mean by that. after we got our root in this case is what? Is x equals to 2, x equals to minus 1. Then we substitute it for when x is 2. So this is our x1 and this is our what? X2. So that is what we want to do. So we want to write how we can calculate that and to calculate the substitution of x in that function. The next one we do is what? We say x1 is equal to x1 is equal to in bracket 2 times what? That root 1 times root 1 times root 1, because if we substitute x, the power was cubed, right? The power was cubed. So since the power was cubed, the root is going to multiply itself 3 times. So we now say root 1 times root 1 times root 1 times root 1, that kind of thing. So we say root 1 times root 1 times root 1. Okay, then we have to close the brackets, minus in brackets 3 times the root 1 in square this time, because it was cube square 1 power, then the other one was nothing, which was the 20. So we close that, then we have minus in brackets, we have the 12, which is 12 times root 1, then we have plus 20, which was the constant that we had, right? So since we have done this, we can actually calculate for x2. So x2 will just be the same thing, right? But we're going to change the root to root 2. So let's just write it, let's end it. So we can say x2 is equal to, in bracket 2. We've already started root 2, root 2, root 2, minus in bracket 3, root 2, root 2, minus in bracket 12 times root 2 plus 20. Okay, so since we've done that, the next thing that I want to do is what? We want to see out, we want to start expressing what we have calculated. We want the user to start seeing what we have done. So the first thing we want to do is what? We want to see out. We want to see out. So what do we want to see out? We want to see out so we want to print out the root, then print out the point. Yes, these are the two things we want to do. Root 1, root 2, want to print it out to the user, then the point 1, point 2 also want to print it out to the user, so that you can have all the 4 points of the curve. Okay, so open and close quotation. So you say root 1, root 1, then x is equal to what? X is equal to, let's say x is equal to the root 1 itself. So for root 1, x is equal to root 1. Yes, because root 1 is this solving, this should be root 2. So root 1, then we need to end line. So end line, we terminate that. So you can also see out. So x is also equal to what? X is equal to, so you can say root 2. So once you come that for root 2, then you can end this line. So we also want to see out. And this is see out. So when we substitute root 1, this should be the answer. We also substitute root 2 for x. Also substitute root 1 for x, this is the answer. Also substitute root 2 for x, this is the answer I get. So we say C out. So C out, substituting the root of x. So substituting the root of x for, okay, let's say for 2 in the equation. So what's the equation? We said y. So y is equal to what? 2x cubed, right? 2x cubed minus 3s squared minus 12x plus 20. Yes, that was the equation. So we've gotten our x1, right? So we can say, are we going to say it's x1, x2, or we say x2, y2? Okay, this one will be what? So this will be x1, let's say this x1, and this is y1. Let's make it have sense. x1, y1. Yes. Then we can now say this is what? X2, y2. So the second point will be x2, y2. So we can now say x2 should be equal to what? x2 should be equal to x1, x2. So it's this point. It's name, we say root 1. Root 1 should be equal to x1. Root 2 should be equal to y1. So x1 should be equal to, so x2 should be equal to x1. So this should be x1 so end line, then we can take this whole long line and say this should be what? x2 for here we know the what? y2. or should we use capital? Okay, let's use capital. So this will be our first statement. So for the next statement, we can say else if discriminant is equal to 0. So we can say open and close curly brackets. So what function do we want in here? So we can say we can see out, but before we start, we can say root. We can say root 1 should be equal to what? Minus b divided by, in bracket, 2 times a 2 times a so say double. So you can see we can double this, right? So if I'm doubling this, we can say Cout in double quotation double root so you can say root 1 double. So you can say end line, right? And we terminate that. So we can now say for in this case, we can also have all of these statements. So in case any statement is printing out, it should also come with this. We can give this to all statements, right? Then for the else case, so we can now say else. You can say else. Then for the else, we can open a function and say in this function root 2 is equal to what? B divided by, so you know the other one was minus b, so now be just b divided by, in bracket, 2 times a then we say Cout so for the Cout we can say the second root so for the second root we can say this will be for the second root. So now say root 2 end line, then we terminate, then we can now paste that same thing we have. So anyone is printing, it should also carry the second point, that is the S2 and Y2 point out. So at this point we can try to test our program. Let's try to test our program before we run it. So let's save this, let's build and run. We enter the coefficient of x1, so it was 2, the power was q, the other one was 8 minus 3, the power was square, the coefficient of 3 was minus 12, the power was 1. So 2 minus 1, 0, and 27. So we can furtherly analyze this. We can furtherly analyze this so that we can get the point. Let's say we want to see out. So at what point do we want to see out? We want to see out at this point. So see out at all points in this case. So see out, we can say we want to see out. We can say the point of the curve. So open quotation so that we can see what we wrote. We can say the points on the curve are. So we need to open a bracket again. So are so open a bracket here. So this bracket is opened. We want to print. Okay, that means we create like this and say root 1. Yes, so we want to bring out root 1. So say root 1 root 1. So root 1, then open and close quotation. In open and close quotation, we put comma. That's what I'm doing. So we can just create this again. So in okay, then we can just say root 2, right? In root 2, we can create this again. So we actually just developing this instance. So we can create a double open and close quotation and put a close bracket in this case now. So we can now copy this up to this point. We can copy up to that point, create this, and paste that one, and create a open, right? So we will now name this one x1, right? We can name this x1, and name this one x2, and we can terminate this one. So let's save, view and run. So I'm going to copy this function and paste it in all cases. Hope you guys are seeing what I'm doing. So I want it to be like, it should look like mathematical form. You get. So let's save this, build and run again. So it was 2 cubed minus 3 squared minus 12 1. So as you can see, the points on the curves are 2, minus 1, 0, 27. So we did it. Wow. So this is really awesome. So as you guys have seen, ensure you're subscribed to the channel because this channel has a lot to give to you. So we have actually created a calculator that can calculate that function for us. So any number we insert, we are very sure it's going to prompt us our correct answer. So we are moving to the next class. So thank you guys for watching. See you in the next video. Bye bye for now.